Great. Welcome everybody this evening in the UK, our UK user group meeting. Happy to welcome two guys from AKT, James and Deyan, from London-based structural and civil engineers, AKT II, who will be presenting first, and then you'll also can see on screen here Scott and Jeffy from McNeel, who will be presenting second, and then we'll be having sort of a joint discussion, a Q&A about what you've seen this evening. So I think what we're going to hear from Scott and Jeffy is some more on recent developments regarding the Rhino.Inside Revit project. Just a few sort of housekeeping things. There is, if you could please type questions into the questions panel, which you should see rather than the chat panel. There's a chat questions that you'll see there. If you could type them in there, that would be great. We'll answer what we can by text, but we'll be putting any questions to the presenters either after the AKT presentation, but then there'll be a more sort of a comprehensive discussion with everybody together at the end. If anyone has any sound problems, which occasionally does come up, please also type that in the questions and we'll just give you some assistance offline if anyone has any problems there. So other than that, I should have just perhaps said I'm Paul from Simply Rhino, which I tend to always forget to say that. And so now we're just going to hand over. I'm not sure, I think we're going to James first, is that correct?
No.
It should be Deyan.
Deyan first. Deyan first. So we're going to hand over to him. I'll see everybody in the next break for the questions just before we hand over to McNeel. So, okay, over to you now, Deyan.
And we should just say that we are recording tonight's session as well. So for anyone. So yes. Here we go. And over to Deyan.
Okay. Hi, everyone. My name is Deyan, and I'm working for AKT. I'm going to show you how we are using Rhino.Inside Revit, in how we are using it in AKT, and how we are taking it into our workflow. AKT is a design-led structural civil engineering company based in London, and we are working around the globe. We have projects in over 44 countries worldwide. Our main office is in London. We have Manchester and Cambridge office as well. We just celebrated 25 years anniversary this year, and these are a few pictures of a few projects we've done in the past. I'm part of the so-called PAR team in AKT, which PAR stands for Parametric Applied Research Team. Basically, it's a team of software developers, engineers, technicians, computer scientists, and so on. We are the ones who normally pick complex geometry jobs, material research, and so on. What we're gonna do today, I'm gonna talk about how we are using Rhino.Inside. So I'll start with a project we've done 6 years ago. This is Bridge Museum. You can see the definition on the top right, which is basically the architect's definition. We take this definition and actually create our own structural model, which is analytical model. This is all in Rhino environment. Then we use this model to create analytical model, and from the analytical model we create the BIM model. As I said, this one has been done 5-6 years ago. There was no Rhino.Inside back in the day. What we use for creating the Revit model is we extract the data from the analytical model to Excel and basically push it back with Dynamo. And I'll explain later why this is not efficient and how Rhino.Inside is much better than that. I just want to mention that we have our own tool that that lives in Grasshopper. So it's inside Grasshopper environment. It's called React, and it's AKT interoperability toolkit. Basically, what it does, it takes geometry, constraints, structural loads, material properties, and basically creates a model. And this model can be sent to structural analysis software like SAP 2000 or Autodesk Robot. It works with Sophistic as well, ETABS, and so on. And this is where Rhino.Inside actually comes really handy, because we can take the geometry and we can extract it to Revit for the BIM model, for the drawing production, and so on. I'll do a step back and actually talk about a bit about the geometry in Revit and why people always find it hard to actually put a Rhino geometry into Revit. Basically, Revit works on industry foundation classes, which is ISO standard for how everything in a BIM model should be put in a separate categories. The types of different geometries in Revit, some of the types are the system families like floors and walls. This is what people will normally model. Then you have the loadable families, which in our case are structural framing, for example, or foundations or foundation piles or columns and so on. You can use adaptive components, but adaptive components don't work very well with structural elements, but there is a workaround. You can have linked geometry, which basically is non-Revit geometry. You can use it to cut sections and tag, not tag stuff, but you can use it in the drawings, but it's a dead object. And if you have BIM coordination for the project, basically it's not gonna go very well. Then you have in-place elements, which are how Revit treats special, let's say, elements. And then you have direct shapes. Direct shapes we try not to use because they don't have volumes, materials, and properties like that. They're just geometrical objects that can be used in the very early stages. This is what the export Rhino geometry to Revit looks like at the moment. So you have your geometry in Rhino and Grasshopper environment. You can start with a Dwg Export. Of course, you're going to lose half of your geometry. It's a dead object in Revit. You're going to have problems with locating it and so on. You can do stat export, similar problems. You can do what I said on the bridge, basically export to another format like Excel, CSV file, text file, JSON file, and then use Deyan to push your elements to Revit. You can export, use third-party add-ins, export from IFC with an add-in, or you can use one of the add-ins that you pay for and they send your data to the cloud and bring it back into Revit. Now, as you can see, the Rhino.Inside Revit is the shortest way between Rhino, Grasshopper, and Revit. And the nice thing is actually it works both ways, which means that you can push data to Revit, but you can also pull data from Revit and back into your Rhino Grasshopper. You have elements tracking. The model location is less of an issue. And why I'm saying that is because if we are dealing with analytical models, which are sent to structural analysis software, this model is always close to 0, 0, and it's orientated either X direction or Y direction. And this is because when you're loading it, basically you want to have your loads in a specific coordinate system. And that's why I think this problem is very nicely solved in Rhino Grasshopper, and you define your vector and rotation. Revit project is set up most of the times far away from 0, 0, so that's always create problems. This is the first project which we used Rhino.Inside. It's a cathedral. Basically, on the top left image, you see part of the cathedral, and you can see the preview. with the central line of the elements based on the structural model. At the bottom, you see a section where this is the balcony in the middle of the cathedral. All the elements are placed. All these are Revit native elements. We use the same workflow for the roof as well, other parts of the building as well. I'm going to show you two workflows as well. So one is the workflow which we use on this project. Basically, we're going to receive an architect's Revit model. Our model is on BIM 360. We extract the geometry for the structural model. We create central lines for our structural model, and we use React to create an analytical model. So we do a few iterations. When we are happy with section sizes and the geometry, basically we push it using Rhino.Inside back to the BIM 360 model and upload it to the architect. This is one of the topologies of this project, and I just want to zoom in a bit. So after creation of the elements, basically, if there were specific requirements for these elements, so they need to, the bottom needs to be horizontal while the side is vertical, and all these elements are different. So what we've done is we created families which got additional parameters, and basically using Rhino.Inside get set parameter component, push angle to bottom of taper length, and things like that. We push these parameters from Grasshopper definition, and basically control this. In this case, they're structural beams, but basically you can control placement point, rotation angle, and so on. So these are some of the topologies. If you can see how, for example, on the bottom left, the edge beams, every single edge beam is slightly differently rotated. All this is coming as a parameter from Rhino.Inside. And there's more, of course. I'm sure if you've seen the previous AKT presentation, basically these are the grid shells. We use Rhino.Inside Revit to push the geometry to BIM. We also use the same way we use it for setting out as well. The next workflow, this is Dubai Creek Footbridge. It's we finished the design at the beginning of this year. The workflow here is slightly different. The bridge is 240 meters long and the span is 145. It's all exposed steelwork. So we receive an architect Rhino model. We convert it to AKT Rhino model. We use React to push it to the and use it to create an analytical model in SAP 2000. Once we are happy with the sizes, we create our Revit model. This is the Revit model. This is the main steelwork, which is approximately 2,000 elements. And this is the rest of the steelwork, which is 13,000 elements. If you setting up a project like this, if you have a good definition, I will say it takes 1 or 2 days, and most of the work is actually on the Revit side, because you have to preset all the families. We have steel with different types of steel in different members, and so on. So the elements that are used here are only structural beams, structural floor. You have bracing as well, structural framing and structural columns. We are not showing the support. Basically, the support was done manually. All the rest of the bridge is created. The BIM model is created using Rhino.Inside. And this is the last project I'm going to show. It's using exactly the same workflow. This one it's a roof, an airport, 10,000 elements. As I said, creation of something like this is effortless comparing to what we used to do. And that's all. The conclusions is Rhino.Inside gives you the power of Rhino and Grasshopper and any other Grasshopper plugin inside Revit. You can access the API, the Revit API, using C#, Python, or Visual Basic. You can link it with analytical software. You can use Karamba. We are using React because it's our own. developers are responsive, and keen to listen to problems and suggestions. The new features are very good, and I think the best thing is how easy you can push and pull data between Rhino and Revit. And that's all from my side. Thank you very much.
Great. So we're now going to move over to James.
Can everyone see that?
Yeah, perfect. Thanks,
Yep.
James.
Hiya. So thanks, Deyan. Yeah, my name's James. I work alongside Deyan, but mainly involved in the structures team. I've been working on structural buildings for about 10 years now. And one of the things we tried to test out recently was the use of Rhino inside with analytical models. So I'm just going to run through in the presentation some of these topics, some of the Revit analytical elements, if you're not familiar with them, an example workflow we used in a project this year in London, how we used Rhino inside Revit to reference in the analytical geometry and section size assignments, and how we used our own in-house toolkit, React, which Deyan has mentioned, to build the analytical models in the desired softwares that we needed at the time. And then I'm just going to cover the future interaction with our AKT Revit template. So the workflow we decided to embark on was to take the architect's Revit model to build our structural Revit model based on initial models from the engineers. So these are local-based, localized models, which eventually form the global model, which we want to build an analytical model of to analyze the movements of the whole system. Simultaneously, we also developed the drawings and schedules, and then at a certain point, we've decided to clean and detach the Revit model in order to make it useful for structural analysis. Now, this is where Rhino inside is quite useful because we can use it to retrieve the Revit analytical elements, push it to our Grasshopper React toolkit, analyze it in the desired software, and then push those changes back into the Revit model and inform any structural changes that need to be implemented. And ultimately, the package is sent for construction. So if you're not familiar with Revit, Revit automatically generates analytical elements whenever you place physical geometry. These are set to automatically join within a set tolerance, but often on large multi-story frame buildings, this can be a bit problematic because often Revit won't get it correct. So you have to do an element of cleaning. So you can see here in the bottom left of the screen, as we place the physical BIM geometry, the analytical elements are created. Now, these analytical elements are placed on their own Revit categories. So generally for structural models, we'll be looking for analytical floors, analytical beams, analytical walls, and analytical columns. So these elements are associated to the physical BIM modeled elements, but they can be manipulated independently. So I'm just going to give you an example of how we can clean elements created in Revit so that they're suitable for analysis. So you can see here, I'm not going to go through all the categories of the analytical elements, but if we take analytical floors, there are 4 main Z-plane adjustments you can make. Typically, we want to have all the elements on one plane, and then typically you want to have all the elements on one plane. So this is quite useful if you have steps in the slab where we want to simplify the geometry for analytical reasons. So that sorts out the Z-plane for floors. And as an example, you can see here the physical BIM model is coordinated on the left, And then on the right, we've got the analytical representation of it. What we want to do is adjust the analytical model to make it suitable for analysis. So in this case, it's a case of picking the analytical element, adjusting the selecting analytical adjustment, and then adjusting them to the grid lines in this case. So you can see here where we have discontinuities, these are highlighted in red, and as soon as we adjust them to the grid lines, these discontinuities should be eliminated, so making it suitable for analysis. So I'll just speed through that so you can see there. Before I let that video begin, 1 second. So as I mentioned, this is one of our projects in London. This was in somewhere near Buckingham Palace. It's a 15-story building, and it's comprised mainly of UBs and UCs. So what we wanted to do in this example is to use Rhino Inside to access these elements, retrieve them, push them to React, and then manipulate them in a Rhino Grasshopper environment. So you can see here we've got Rhino Inside installed. We click Rhino, it launches up Rhino within Revit. We access Grasshopper, and we're just going to place down a graphical element selector. We use that to select all the elements in the view. Once we have that, in this case, we only want to select the Revit analytical framing. So we're just going to create a analytical Revit filter, so that we only select these elements in Grasshopper. Just speed through. So we're just going to create a filter which creates a Boolean of yes, no's, and then we're going to filter our element selection based on that Boolean output. Just going to speed through. So you can see here we've extracted the Revit geometry, and this is live in the Grasshopper environment. But one of the issues is when you bake this geometry, it's going to be segmented, and this is just Revit's way of separating the start and end points of analytical framing. So we obviously want to join these elements together to create a single unified curve. So you can see here now, once we've unified those elements and joined them together, we've got joined curves. Simultaneously, because of the elements in Revit, we can now access the section size assignment through the parameters. So if we then take our list of elements, retrieve the get set element parameter component, so we can feed in our elements and just feed in the parameter name that we want to retrieve. So in this case, we've got a list of family types, which we then can retrieve the section sizes that are assigned to these curves. So we now have a list of section size assignments and a list of the geometry associated to it. So it's then a case of repeating this process for all the different Revit categories, so walls, floors, framing, columns, and then we can build our structural model and push it to our React toolkit. So one of the issues we encountered was that we often have custom sections. So you can see here typically UBs and UCs, and these families in Revit have their own custom parameters, as Deyan mentioned in his previous presentation. So in this case, we're going to use Rhino Inside Revit to access these parameters and then feed that into our React toolkit. This is just a summary of the script. So we have our analytical walls, floors, framing, and columns. One of the useful tasks that we were able to do for analytical reasons was to do additional post-processing in Grasshopper. So in this case, you can see here the floors in Revit were done as one large surface, but actually we wanted to create individual panels because of the nature of the structure at the time. So it was a case of taking the analytical framing which you'd extracted and then splitting it with the floors. So you can see here we'd have had individual panels which we can then create meshes out of for analyzing. Something to note is that because the model was developed in Revit, the list structure is very easy to control. So all the levels and all the elements were associated to a level. So it's very easy to access the various branches and retrieve data and localize what we need. Something we also did was to bake the geometry. This is just useful for visualization and for localized checking in Rhino before being sent to analysis. And then, as Deyan's mentioned, at this point we had extracted all the walls, floors, framing, and all the analytical geometry from Revit, and then we wanted to integrate that with our React toolkit. So as you can see here, React is just a platform that interacts with various structural analysis platforms. Data is exported in real time and then converted to AKT core elements, which are then filtered and reformatted to make them suitable for the desired software chosen. So here's just an example of that mapping process. So you can see here the Revit section size assignments in sort of UBs, UCs, in this case steel beams, and these are mapped over to React based components to make them suitable for analysis. Something to note as well that in the company we have a wiki, we have an internal wiki which we then use to host a set of templates which then all the engineers can access and build analytical models based on our React toolkit. So at this point, we had all the framing from Revit and all the geometry nicely cleaned and organized into a nice list structure. It was a case of accessing one of those templates that we've set up in the company. So in this case, it was a 3D multi-story frame template, and then just feeding it into the template information on the right. So in this case, we've got the analytical framing from Revit. We're feeding it into one of our React components, which generates the structural model. So we're just going to feed in the analytical framing from Revit that we've extracted, and then the clean section size assignments. So at this point, we had all the supports, columns, framing, the core, and the walls, as well as the slabs meshed, and these are all then fed into our main React component, which we then can choose which software to send for analysis. So in this case, we're going to be choosing SAP 2000, and as soon as we choose SAP 2000 and launch it up, it should send the command off via the API to the program and boot it up and build the analytical model. Something we're also investigating on is how can we push the information back from the analytical model into the Revit model. This is typically done manually, but might be something we want to experiment and test with through a JSON file or some sort of Excel. And the aim of this is just to build up the Revit library that we have in terms of the model, and then ultimately push those results to Revit, which then can be visualized in form of drawings and connection forces in this example. And I think that's it, guys. I want to hand over to Scott.
Perfect. Thanks, James. So we're just...
Yeah, we're just going to see if there are any questions before second presentation. There was just one thing that I come through that I could perhaps ask quickly now. It appears that, I mean, the question is something. I'll just read it as it is here. It appears that you kind of quite sensibly started with Rhino inside Revit some time ago, starting on some smaller, I don't know whether, pilot projects. I mean, where would you say you are now with your, I mean, the question is really about confidence levels and whether you are, as a practice now rolling out this same approach for, larger projects? Is there a limit to, your confidence level at this point, or, could you comment on that?
Yes, I can comment on that. We start testing after the presentation. Actually, in our office was the presentation, the Rhino.Inside initial presentation. It was just before the pandemic, and during the pandemic, actually, we start testing it on small projects, which we'll use Dynamo. So we start replacing slowly Dynamo, and I think now it's full on Rhino.Inside Revit on large projects.
Okay, so confidence is high.
Yeah, I mean, just to add to that, yeah, it's not just the complex geometry projects we want to test it on. We want to use it on sort of the standard offices and the sort of buildings you see on a lot of the jobs in the company.
Okay, I think what I'll do is, there are other questions coming through, but it's probably best that we hold them to the end, and then we can all discuss them as a group, involving the McNeel guys as well, if that's okay. So I think we're going to hand over to Scott now, Steph.
Yeah.
Okay, so we'll see you all together at the end for the big discussion. Okay, thank you. Over to you, Scott.
Over to Scott.
All right, hopefully, hi everyone. So hopefully you can see the Rhino.Inside Revit slide that I have up. The first of all, I want to say that coming to this group, I usually come every year, and it is by far one of my favorite places to be. And unfortunately, the last 2 years haven't been able to do it because of COVID. But I just want to tell everybody I miss all you guys, and hopefully, as soon as we can, we're going to get back over there so we can all sit down and talk this out. Anyway, I just want to talk generally. That was a great presentation. So it's going to cut my presentation much shorter. Thanks. I wanted to go over kind of where I think we've been, where we are with Rhino.Inside Revit, and as we get down to the end of this presentation, what we're experimenting with. So, kind of draw the curtain back a little bit. Some things might get a little rough here by the end, but I just want to kind of show what we're thinking about, what we're playing around with, and kind of go from there. The other thing that's really important, and as you already know about the way we work, is that we're driven almost exclusively by what you request and what you ask for and what you're trying to do. And so please, get a hold of us when you're working with the product and ask questions, and if there's things you want to do and can't, we want to hear about that, because that's really key to what we do. And hopefully maybe I'll have a couple pointers that we have. So we started Rhino.Inside Revit, and it was really the classic start of or what everybody would kind of think about is how do I get my Rhino model into Revit? And that's really where Rhino.Inside Revit started in terms of what we were trying to do. And over the last couple of years, it's evolved quite a bit. So we were able to do that. You take one of the first kind of examples is you have a model in Rhino, and you want to do some quick drawings, for instance. And so we can take we take this model here, and using direct shapes and just really quickly, we can categorize everything properly so that you can get a set of drawings out of Revit from the Rhino model. And I know direct shapes aren't the thing that everybody wants to use in Revit for actual production, but in terms of something really quick, something that can be used, and these drawings update. So once you set up your drawings and you change the Rhino model, then these drawings can update once you push the model over into Revit again, and all the categorization and the graphics and things are remembered. And so that's an area that we kind of started with this thing. One of the things we've added in the last year since we last talked was we have element tracking now. So if you have, if you're in Rhino and you push across to Grasshopper, Grasshopper components remember the objects that they created, so that when they update again, they either modify the existing component or they create new components depending on what they can and can't do. But you won't get duplicates, so you don't have to remember of deleting the old versions. Even after you save, it'll even save now after you save. So that's a big feature that we added, last spring, that really changed the way you might think about this. So stepping a little bit beyond just taking geometry across is one of the things we did in AKT II is a great example of this. Is now you can also to start to control categories, objects and subcategories, creating families, doing things like that. And so now you can start to categorize your objects in Revit, using the family type instance process, and also using subcategories and display overrides and all those kinds of advanced things that you would use for your BIM schema. And so now you can actually push, you can actually start to map your Rhino organization to your Revit organization, and really allow those things to happen in a way that somebody using Revit downstream the model would feel a lot more natural. So here we have an example of a complex geometry shape that's getting pushed across, and you can see in the plan view, for instance, we're changing the line types based on the subcategory, and different views and different drawings can have different pieces in Revit. The model will hatch properly. These are real NURBS objects, and so you'll get a good hatch in Revit when you change things and go from there. So that's kind of the next place we took this thing. Now, a lot of people started to use Rhino.Inside Revit to actually pull the geometry the other direction, and so this is an example of taking all the spaces out of a Revit model and then doing an adjacency study, for instance, in a building, and using Rhino to output the graphics and the colors and the usage of the program. And we see that quite a bit. Closely related to that is, for instance, using any of the Grasshopper plugins, which AKT II has showed. You use any Grasshopper or Rhino plugins now run in Revit. And so a good example would be Ladybug, grabbing the complex geometry out of Revit, using Rhino and Ladybug to simplify that geometry, and then doing the Ladybug analysis, and actually can push those numbers back into Revit if you want the results. If you get really good at it, you can do optimization. So you can actually have Revit change the model based on what Grasshopper and what Ladybug figured out. The React plugin is a great example of this too on a structural level. And so we're seeing a lot of people do that piece. And that's something that we've seen quite a bit of, and that's something else that you can do. Another thing that you can do this is using the Semantic Plugins from Proving Ground, Nathan Miller. So taking that information out of Revit, doing some analysis to it, square footages, whatever you might have, and then actually pushing it up on the web, and having the ability to have some reports, see the 3D information, things like that. So in some ways, this is just using yet another plugin from Rhino and Grasshopper in Revit. But it is a great example of how you can now, push a lot of this information up on the web. This is an example of using, in this case, Sophistic to do, but you could do this with React. You could do this with any of the structural analysis products, is doing an optimization. So doing some optimization by sending information back and forth between different products, and then using Grasshopper and its ability to doing analysis and looking for solutions. And we expect that to grow more and more as we move forward. So once we worked on that, you know, those kinds of pieces, which we've talked about a little bit. I want to show, you know, some a piece here that we have. Let me see here. Let me get Revit up in front. So one of the things I wanted to show is you know, we have sending geometry back and forth. We can now create, using Grasshopper, we can create a number of more native Revit objects. A good example of this is this floor, for instance. You know, so from a Rhino curve, I was able to create a Revit floor. So those update automatically. If I change the Rhino floors, the Revit floors will automatically update. But what's nice about this, if I want to, is I can come in here and let's grab let's grab this floor here, and I need to unpin it. And so yeah, it's right there. So I can come in here and I can actually edit this boundary. And if I click on it, you can see that I actually get the values of the boundary, the distances, and I can go in with Revit and actually change this. So if you disconnect Rhino and Grasshopper from this model, you can still edit these floors just like you would be able to edit them in Revit, as if they were created in Revit in the first place. And so that's an important part of the process, is that we've gotten to the point where sometimes in some you know, some models we can do this, some elements it's still not possible to do all this, but you can go in here and you can edit some pieces just like as if they were in Revit. So people that are worried about their BIM schema or messing up their models, you know, we're working hard on trying to give you more options to do that. I'm going to cancel out of this right now just because Grasshopper is still in control of this model. You know, we can do that type of work. We can also, I can come in here and I'll enable this one. And what this is going to do is it's actually going to go through and it's going to create adaptive components. Adaptive components is a place that's pretty popular with Rhino inside Revit. And what we can do is using, you know, some tools in Grasshopper, I can come in here, for instance, change to different panels that are randomly placed based on where, and so Grasshopper, you can go and optimize patterns and work on that, or you can do things like on the edges have certain adaptive components, and in the middle have different adaptive components. Jeffy today is going to go over a little bit about how to work with multiple panel sizes and get them ready for production, things like that. So I wanted to just kind of take a left-hand turn here for a second and talk about something that's kind of hard to understand from our process, but it's something that's super important, and that is understanding which build you have in Rhino inside. So if I go here to the toolbar that we have in Rhino inside Revit, I get to the start button and I have a more button down here, and there's options here, and you can see this red mark here. This red button here, this red dot, means that there's a new update. So I don't have the newest update. And to understand how that works, we'll drop down here, go to options. And what is important to understand is that we have 3 different builds of Rhino inside Revit that we're constantly working on. And depending on how much change you want to see, or on what cutting edge, you may choose one of these 3 builds. And so we have the public release, and that is the release that's been the most tested. That's the release we'll consider stable. It currently updates once a month, just on a regular schedule. And that's that build doesn't change. Like once it's a public release, that build doesn't change, and it's again, it's the most tested version of it, and that's the one that by default gets installed. Now, if you are somebody that wants to test the next version, the next public, or the next what we're going to consider stable, if this is especially true for people that are responsible maybe for a team of people, and they want to make sure that the new build, if they're going to update, that the new build works for them and isn't going to disrupt the process, that would be a release candidate. So the release candidate is the build that we have that we won't add we add the new features to the release candidate, but once they're in there, we don't add new features to that. We just fix bugs. And that release candidate is released every week, and it is essentially just a test version for what we're going to consider stable, at the end of the month. And so for people that want to test a build before it is released, so that they can, for instance, update everybody when it's released, the release candidate's a very good place for that. And the third one, which is the most cutting edge one, which is our daily build. That's the one where we put the new features in, we check things in that aren't maybe ready, but we also check in what we're experimenting with. It's a great build to have if you want to, if we're working on features that you want right away and you want input on how they're put together. And sometimes, most of the time, the daily build features will roll right into release candidate every month when we update this process. Sometimes not, depending on how good the daily build features are. But I wanted to show you this, that you may even have different people in the company on different builds, depending on where they are in the process and how cutting edge they want to be with the new features. All right, and so once you pick one of these things, one of these builds, then this update, the red updater here will highlight appropriately when there's a new build. Like on a daily build, you can actually probably have a build more than once a day if we happen to do that, but it also doesn't necessarily come out daily. But that's one of the parts of the process that I wanted to take a little side trip here and talk about that. Okay. So let's start talking about where we're going next, or where we have been, I guess, in the last few months. Is one of the things we're doing is we're moving a little bit away from Rhino to Revit and Revit back to Rhino, and we're starting to engage Revit on a little deeper level. We're starting to engage Revit on, let's call it the modeling side of things. Let's talk about, developing the model, creating routines to make it easier to have more intelligent models in Revit. And as an example, what we're going to show, I'm going to have Jeffy show here using assemblies. And so assemblies is a new feature that we've in the last few months have released. And so we support Revit assemblies, and the ability to have more intelligent assemblies is quite interesting. So I'm gonna stop sharing here, and we're gonna have Jeffy show a little bit of an assembly routine that he's been working on.
Okay, cool.
Okay, can we see this?
Yeah.
All right. Didn't think we were doing assemblies first, but I do have it open, so. Just a little, so we have a curtain wall, various panels, and okay, so this is our newly added Revit Assembly component. And what we're doing here is gathering all the curtain panels in the project, as a filter, grafting, and creating assemblies. So this is a Revit assembly. Some people aren't too aware of this kind of element. It's been around for a while. It's more of a post-process thing that Revit put in. So once you're done with your model and you're ready to document it quickly, you can make an assembly, and it kind of isolates it from the rest of the project in a way for documentation. So here we go. We added that assembly, and what that did is over here. Well, let's go ahead and fire up our preview. So what that did is create our assemblies. So it's going to group them by like size. So what was once a curtain panel, got all these over here, is now an assembly. So we have about 10 unique assemblies. Once you have an assembly, you can create assembly views, which will make a sheet, schedules, 3D, like a 3D view isolated on its own, all from this assembly, create assembly interface. The interesting part that Revit does is, so let's see if I can get here. So right now we got 6 foot. So let's make these both the same. So if I was gonna select this in the project browser, select all instances, these are all the same. Now, if I make this a 4'6", or actually let's do the other way. See, we lost an assembly here. I get my Grasshopper back, refresh. Now these are all grouped as the same size element. So Revit in the back end is seeing what size the panel is, what its properties are, and are creating likenesses. So what this does in the future, sign. So here's a curtain wall with an advanced panel that's already made into assemblies with no drawings. And we'll go here. So the first thing we're going to do is, so I've selected which views I'm going to put on the and create. So I push the button. It's going to create our assembly sheet and a view to the left. I'm going to refresh this one. So take a second.
Performance is always, performance is always a little slow when we're broadcasting and running Revit and Grasshopper and all these things all at the same time. So one of the things to remember as you're watching this is that, yeah, broadcasting across and streaming definitely gives a markedly different performance.
Yep. There, we created our 3D view. We're gonna put that on the sheet as well. Refresh. We also just created our schedule. and put that on the sheet as well. So in a matter of, oops, it's like I missed a button, but we've created our sheets, isolated the panels, put the information on, and whatnot. This one, that one. There we go. There's our 3D view on the sheet. So that's kind of where we're heading. Post-processing. Scott, did you want me to talk about this one?
Yeah, that one's really great too. It's that first one was you know, we're experimenting more and more, being able to auto generate some layouts and sheets. And this one, yeah, this is a great example of getting more into the modeling with Revit. Definitely.
And I'm going to put this link in the chat. Made a little intro video and posted the files. Requires Elephant, Revit 2022, and kind of an older version of Rhino inside Revit. The new version will work. It might throw an error, but as soon as you save, your definition is going to be updated. What we have here is some structural, along with a floor slab and some unistrut hangers that were put in. And this is an example of trying to do things that you can't do, Revit can't do by itself, Rhino can't really do. So we're gonna mix the two together and do something completely different. So what I've done is reference all the steel members, all the floor slabs, got their geometry and made a preview. I've also got the unistruts in the view, got their location and the length of the line, and created kind of some temp geometry of a line that's going to intersect our steel and our floor. And so we don't know our spacing yet. So say we haven't had our engineering, anything like that. So what I'm doing is running a collision, and then so that collision is going to give me the location and also the distance to where that object collided. And then we could place our Revit family. Let's see, get a better view. There we go. What it also, so it's getting our height parameter that we're filling out in the Revit. What that is also doing is telling us what type of object we're hitting. So in the case, I've made a family that has two types of attachment, one for concrete, one for steel. Since our collision knows that it's going into a floor, we're going to put our attachment for the floor. We're going to put our attachment to the beam. And with our Grasshopper script running, this kind of creates a really dynamic situation where if we move our floor, let's see, up to 2, it's going to move that. I need to refresh to get my attachments right. Change the beam size, which I only have one size, so let's duplicate that real quick and make that bigger. It updates that. So it creates a way more dynamic workflow than just Revit alone or just Rhino alone. And You can see the whole time it's updating the schedules. If we go back to our Grasshopper, Rhino. We start changing some stuff here with our spacing. We're going to update our schedules, update our placements, and do some really cool stuff. Yeah, so once again, that's available. The script's available in Revit 22. I put the link in the chat. If you have any questions, I can answer them a little later. Scott, did you want me to keep going?
Oh, I can talk here for just a bit. So these are a couple things that we've been working on here. You can see using assemblies, being able to create things in Revit that kind of become more complex in terms of certain things are related to another, and then they're grouped, assembled together so that they can be handled as an assembly. It does really allow for a lot more sophisticated work. Another area that we've worked on quite a bit, and we're just hopefully rolling that out, is an SDK, an API. And one of the things, and AKT II has been doing some of this work, is one of the real powers of this is that you have now access to the Revit SDK and the Rhino SDK and the Rhino.Inside Revit SDK all in the same place. And so whether you use Python or you use C# or you can create components now that actually are they're plugins to both products at the same time. And in fact, they're actually in the same memory space, so they interact with each other. And so you have all the best of Rhino and Grasshopper and all the best of Revit all in the same spot when you're programming. And we're working on currently, this is really newest stuff, is we're currently working on the ability to use Visual Studio and to create actually Rhino plugins that use the Revit API. So you can actually create Rhino plugins that when Revit's around, it can use Revit's API, and when Revit's not around, it'll load and you can do other things. And so that's one area. We're also, of course, Isan, whose PyRevit product is out there for Revit, and it supports Rhino.Inside Revit also. And so, if you use Python to do some quick scripts, I know Jeffy uses a lot of Python components to prototype his workflows. And that's something that for those that know a little bit of Python, that's a really powerful position to be in. But one of the things we're going to do is we're going to continue to push more API, more SDK, more methods from both products, and try to make it easier for you to create custom solutions on top of what you're already doing. And just one last thing we want to show here, and this is really, really rough, is some people like to, depending on the situation you're in, some people will take Rhino and Revit and create drawings in Revit. That's a very powerful process that Jeffy's been showing here. Some other people in their process actually want to try to create Rhino. This is true, especially in fabrication. They may want to create drawings in Rhino instead of in Revit. And so you take information out of Revit, you put it in Rhino, and then you actually create some drawings. And so I think Jeffy may have an example here of kind of starting to how the process might work to create some drawings, or at least start the idea of creating drawings in Revit or Rhino. I'm sorry, Rhino. Yep. Is that right, Jeffy?
Yeah, and I mean, this is a new one. Working on it, was working on this morning. Hopefully I'll put up a video and the files up to the Rhino Inside forum area. And yeah, if you ever have any questions or want to figure out a workflow, feel free to post something on there. We're getting some great help. So in this demo, really, the big thing is just how we're getting data from Rhino or from Revit to Rhino, then Rhino to Revit, and then some of the things we can do with it. So I'm going to put a curtain wall right here. Doesn't have anything. We're going to add some grids, kind of like we did before. Do a few different sizes. There we go. So right now this panel schedule has nothing. All right. So what I've done is used our query categories, got our walls, got the curtain wall, and applied some parameters. The next step in this, what it's actually doing is baking into Rhino. This is using the Elephant project plugin once again. It's one of my favorite ones. It has some great tools for adding user data to our project. So similarly to the assembly, the blocks come in grouped. So if I select same block, these panels are all the same. So it's that same background Revit process that's figuring out which ones are alike is used to bake our Rhino blocks. These blocks are going to have the same data applied to them that was in our Revit schedule right over here. I'm also, since it's a block, it comes in with a nice plane that I'm able to kind of group them, get one instance, and place on our XY plane, ready to make some drawings. Another big thing I wanted to show is how now that this data is in our Rhino, let's see if I can get you a better view here. And I want to change our comment to a yes, so maybe a discussion item. Yes. That updates our comment parameter here, which has a view filter highlighting it. So in this example, we've created the data into the Revit, and we've also pushed our data back into the Revit dynamically. So let's keep going. All right. So here in this definition, we're gonna use the elephant once again to reference our geometry, our blocks. They also have some components that allow us to put dimensions. So we'll put our dimensions on. In this one, I also have a template file set up for a sheet. And this is using another plugin, Fab Tools. It's a little outdated, but still works. So what that does is create a sheet for every one of those unique panels. We could set the view and set our bomb view, which we haven't created yet. So what I've done over here is gathered that same information using Elefront, our starter and end clips. So I could create a quick bill of materials of those panels using the same information that we have over in our panel schedule. So yeah, there we go. I'm sure we'll have a couple questions.
Oh yeah, it's question time. Paul, Stephanie.
Fantastic. Well, thanks for that, Scott. Thanks, Jeffy.
Certainly.
Bring back get the other two guys.
The song's around here somewhere too, I think.
Right, we're all here. Yes. Okay, so all questions welcome. We've got some questions here, but please keep the questions coming. Of course, for James and Deyan, if you also have any questions for the McNeel team on what you've just seen, that's they're welcome to, and vice versa. If there's any questions there, but perhaps so if there isn't anything immediately, I'll start by reading some of the questions out. But was there anything at all that anything from you, James or Dan, so far based on what you saw there? No. Okay. Well. Okay. Well, let's start with some questions from the attendees. Okay.
The presentations were so good that there are no questions.
Okay. What plugin was Jeffy using to create layouts in Rhino? I know that was Elefront, wasn't it? That was the last part of the presentation. That was Elefront, wasn't it?
Perhaps a combination of Elefront as well as Fab Tools.
Yeah. Perhaps we can put a link to that in the chat, because I think some are not familiar with it.
Certainly.
On Food for Rhino or wherever it lives nowadays. Okay, something else here. Something about well, how does using Rhino Inside change? From a hardware point of view, are you seeing that? Do you have to think Revit plus for a machine specification? How does that affect things? Have people got opinions on that?
Well, it uses the same amount of memory that Rhino and Revit running them at the same time on your machine is. So there's not a lot of overhead there. So it doesn't really demand any more hardware than already these two hardware hungry programs already want. So if you have a machine that runs Revit well, then this won't be an issue. And if you can run Rhino well on the machine from a graphic point of view, then they all relate together. But there isn't a lot of additional overhead. You will find that Grasshopper sometimes feels slower when you're running in this thing, mainly because Revit is inside the definition running some things where we have to wait. But it's still the performance actually I think overall has been really pretty good. So
okay, thanks, Scott. Right, let's see. Someone's asking, these are your sample files, Jeffy. Are you able to share the files that we just saw? Perhaps you have already on the Rhino Inside sites, but yeah.
Yep, Yeah, certainly. Like I said, I kind of break those into smaller parts. The most recent, the last one I showed, I could certainly share it as is, but I would expect in the next week or so to have an example and a video explaining a little more.
Okay. Okay, just in some are keen to get their hands on those files.
No problem, no problem.
Okay. Right, so a question from Isabella. I'll just read this out. I've been using Rhino inside Revit for some time for modeling bridges using workflow 2, as shown by Deyan earlier, if we can remember that. I would like to know if direct shapes are the only method of modeling structural elements with varying cross sections, e.g. steel plate girders. I found it impossible to create Revit families with varying cross sections. Hence, I use direct shapes for these. Is there an alternative?
I would note that I actually kind of like direct shapes. I know, like you're saying, they don't have some of the volume, some of the kind of system parameters from Revit. But if you set up, if you have those feeding in from your Rhino, so you'd create your own volume. The direct shape, add geometry direct shape will take a material. So it's a slightly different workflow where you might be replacing your objects more, but the direct shapes work well for like that kind of geometry that Revit's not gonna play nice with. So.
Okay. Thank you. I hope that helps, Isabella. If that's something else. Oh, sorry.
I don't know. Dan might be able to help with this too. Is that if you create a family with a component in it, I don't know if you can create a family. And what's the category you're trying to use? What's the category you're trying to use to create the structural shape? Oh, you're muted. You're still muted.
Sorry, Dan, can't hear you.
Yeah.
Well, maybe it should be structural framing or structural columns.
So structural framing, can you create component families in structural framing? And
yeah, so we've encountered situations like this where we've got a very unique geometry. So what we usually do is we bake the direct shape into a family, which enables you to access to have parameters like volume to that element.
Oh, and you add parameters separately to
yes,
volume.
So we would add additional parameters which don't control the element, but they are schedulable. So we would add shared parameters, which they're dummy parameters essentially.
Have you been able to create? Can you create in those categories component families, or are those system style families only, other than direct shapes?
Well, are you referring to loadable families?
Yes.
So we've structural framing is a loadable family. So yes, you can bake.
So in that case, if you want that, so we have direct shapes, and then you loadable families. If you have a good closed NURBS model, you can actually load that as a component type in
Revit.
Right, in Revit, and Revit then will get volume from that.
Yes, as long as it's closed breadth.
Yes, all the rules of Revit. Yeah.
But obviously, you will lose the intelligence of being able to manipulate that if you had to in Revit. It's something we'd avoid, to be honest. Okay. It's a last resort.
It's also if you have a lot of elements, that's going to be a problem. Like thousands of elements, like the one I show on the bridge.
Yeah, unless the only other option then would be you'd have to pre-sort and use instances, have a family and one component and
which we try to avoid. Yeah.
Well, it can get complicated when it that far. Yeah. Okay, this is good. hopefully that helps. That's it.
Yeah, well, hopefully that helps you, Isabella, but feel free to ask another question if there's any part of that we've missed. It's also possible, you know, if anyone wants to put their hand up from the audience, to turn your mic on and you can ask the questions directly. So, you know, if anyone's brave enough, you'll be very welcome to speak to us. Okay, so question from Drillon here. Since the code is open source, I know it is possible for all to contribute. The problem is that the code is quite complicated. Are there other ways to contribute in the code with some components that I have scripted myself?
And you're scripting in C#?
Yeah.
Or you're scripting in Python? The answer is
yes.
Absolutely. Yeah. The answer is sure. You know, one of the things that you can, well, and Hassan better stop me when I go off the rails here, but you can, you know, you can write up your own stuff, and you can actually just branch it and contribute your code. I mean, you're not contributing it to integrate it like that, but you know, there's no problem with creating the code and creating a branch and making a pull request, essentially, so we have something to discuss. Absolutely. And then, you know, whether we want to integrate, you know, need to integrate it because our code's complicated, absolutely, or we want to lead you to in a way to help you integrate it, that those would work. But Hassan may have a different idea on that one. But
no, really, and we sort of like, we're still working with the API too, so there are like more and more features are going to be accessible to the scripted components as we go along. The goal is to get the scripted components to a point that they are as good as the native components that we have, so you can almost pretty much do anything in there.
And this week we released one of those. So, you know, if you get to the daily build, you can see what we're doing with the SDK and the API. And I mean, literally, it's like this next few weeks, you're going to see a lot of new stuff for that. But yeah, we invite you to contribute. And if you're finding you're having a hard time contributing, please get a hold of us and we will try to make it easier. So.
Okay. Right. Perhaps the question from Shadi. Okay, yeah, Drillon said he will definitely do so, so that's good.
Great.
Right. Yeah, this might be something that that Deyan and James have perhaps come across as well. Are there any ready components to generate 3D reinforcement for concrete elements? How would you how would you comment on that?
We never, to be honest with you, we never come across 3D reinforcement with Rhino inside, so I cannot comment on that.
We don't really have any components at this point, but not because, it's mostly because really nobody ever asked for them, to be honest with you. But it's, you know, it's anything that's sort of like possible through the Revit API. We can either create native components for it, or you can access those features if you want to use the scripted components and sort of like write your own custom version of creating these kind of stuff.
Yeah, and it's not as hard as it sounded there, but the you know, like whipping up a quick Python component that would create one of those, if it's possible through the SDK, and that's what we got to, you know, that's what we all would want to research first. But if it was possible, whipping up a small, quick Python component, and you'd be able to do the workflow with that component, that's very easy, and that's something that, for instance, asking on the forum is a really good thing, because there are a number of people that could help you, including some of our people. But just having a component that does if it's possible to do one, then you can use it and see how it works for you.
Paul, is it possible to get the screen back one more time?
Sure.
Yeah. No problem. Jeffy, over to you.
Okay. Yeah, this one might break. I wanted to show it. I just pulled up a random sample project, but this is something that just got put in a week or so ago. So we can query our views. In this case, the detail view. Also, I've got the walls, and I'm doing a little custom preview in Rhino. So what we can do now, since we have 9 detail views in this project, if they'll cast to their bounding box. So that's the box of the view. They'll go to a surface or a plane, and then as well as a material. So with the custom preview, it's taking a live snapshot of the detail and putting it on that surface that detail is cut through. So if you wanted to page through all the details in the project, kind of make sure your 3D is aligning so they're a little off in your project, that's now possible.
Yeah, and you can have some fun with that. You could have, those could be links to models, or they could have extra additional user data on them, and you could do a lot of things with those 3D placed detailed or 2D versions of the 3D, slices and dices. So it's pretty cool. Those, of course, aren't dynamic. They're pre-made over in Revit. But anyway.
Yeah, so yeah, if we went to that detail and moved this dimension up, we came back, that dimension would move up too. So, okay, yeah, I just wanted to show that last one. I thought that might crash the machine, but since I have all these Revit instances open, but it looks like we made it. So,
yeah, very good. Thanks, Jeffy. Okay, okay, a couple of other things. One question that's come up offline is how does this, it's for the AKT guys, how has this affected your, teams, and the skills required now that you would look for from a typical individual? I mean, I guess the question comes from the point where perhaps it was easier previously to separate skills, whereas now, if someone's going to be engaged with these projects, they're going to have to have a high level of knowledge of Rhino, Grasshopper, Revit. So it kind of condenses things. I suppose the question is more, what are your views on that, and how has that changed, the sort of working patterns and how teams are made up in your office now?
Well, it's a valid question. Actually, it's a very good question, because in AKT, for example, we have a very clear separation of who is using Revit and who is, we have people, they are called technicians, and they specifically model stuff in Revit. But of course, there is at some point there is a bridge actually between the two, and the engineers will have a very strong opinion on their analytical model. The technicians will have a very strong opinion on their BIM model. So basically, there is a bridge. There's specific people. We're trying to place one person per basically team. We have internal group of users people who basically use Rhino inside Revit. And what we're trying to do is let specific people who are trained in Rhino and Grasshopper do specific tasks. And there is one person per each team who can handle projects like this. Probably not the most complex tasks, but let's say a simple export or getting analytical model from analytical model to actual Revit BIM model. But it's not going to happen on every single person in the company, basically, who's got Revit license, because of the limitation of you need someone who knows what the data structure is and how Grasshopper works.
Yeah. Okay. Okay. Yes. Thank you, Dan. Yeah, I suppose this is sort of linked to the same kind of thing. What does this really mean for the use of Dynamo in the office now?
We have a lot of stuff which has been done in Dynamo in terms of we have our own scripts, like lots of scripts that are basically automating tasks, Revit tasks. Now what we are doing is we are trying to switch to C# scripts done using directly Revit API, but still all the Dynamo scripts are there as backup, and we still have people who are using Dynamo, I think, on specific projects because they have been started that way, because this is what people want to use. We don't want to discard Dynamo. I think Dynamo and Rhino.Inside will live in parallel lives. It's not like one will eat the other one all of a sudden. But this is my personal opinion. I mean, other people will tell you a different thing.
Sure. Okay, thank you. Okay, well, I know Scott had to go at 8 o'clock, so he's disappeared. But he did.
Yeah, he and Jeffy are still here.
Sure. So unless there's any final questions, I mean, we were scheduled to finish at 8, and we're quite on good time for that. But if there's any final questions, we could ask them now. Otherwise, we're going to finish. So let me just do something here. So I'll begin to wrap up. So unless we see any final questions, I just want to thank Deyan and James from AKT. Thank you very much for your presentation earlier. That was great. Jeffy, Asan, and Scott, thank you for joining us. I just wanted to repeat to everybody that Rhino Inside Revit, the whole project came about through requests from customers. So keeping in touch with McNeel, either via ourselves or directly through the forums, is how these things get created or are improved. So yeah, I just encourage all of you to never be shy with coming forward with ideas, certainly for ideas on improvements. So so just thanks once again. We'll be making announcements soon about meetings in the new year. We hope to start scheduling some more meetings, or the first new set of meetings in person. Who knows? We're sort of waiting to see how things go with in the news for everybody about COVID and whether we're going upwards or downwards. It doesn't seem very clear here in London at the moment what direction we're going in. But anyway, thank once again, and so we probably won't have a meeting before Christmas. So just all the best for that and the new year to everybody, and we hope to see you all in the new year. So once again, thanks everybody, and see you soon.
Thank you.
Thanks everyone.
Cheers,
Bye-bye.
guys.
Happy Thanksgiving, everyone.
Bye everyone.